Okay, so let's do a substitution problem. First, we have to get a letter by itself. I chose Y. Didn't matter. So move the X over. Put it in parentheses, of course. Go to the other equation, take out the Y, put in the parentheses, and now you'll see that everything is X's. There are no other variables, which means I can solve for X. Got to distribute that 4. So now we're going to combine like terms and move the -4 over all in the same step. And divide by -1, and you get -8. Remember, that's only half of our answer. So now we got to go to one of the equations. Doesn't matter. Substitute that -8 in, put it in parentheses, and then simplify, and you get y equals 7. Remember, this is 2 lines. I want a point, so we put it in an ordered pair, -8, 7, and we have an answer. All right, so here we go again. This time I'm going to get the x by itself. And this one is a little bit of a weird one, so I don't really have one like this on the test, but you might as well see it. I take out the x, I put in the parentheses, and now everything is in y's. Distribute the negative. Combine like terms. And you'll notice that the variables disappear. So when you don't have variables, you just read it out loud. -9 equals -9. That's a true statement. And when we have true statements, we say that there are infinite solutions. And that is our answer. So on this one, we have to do it by elimination. So we have to choose which variable to get rid of. I chose the y. I can turn them both into 12s, but one of them has to be negative. So I chose the bottom one to be negative, which means the top one can stay the same, 6x plus 12y equals 0. But I have to multiply the bottom one by -3. And I'm going to multiply each term by -3. So we get -12x minus 12y equals -24. Now I can add them together because elimination is the addition method. And I get -6x equals -24. And I can solve for x and get x equals 4. Now I have to take that and substitute it into one of the equations. I chose the top equation. Put the 4 in there. Do a little bit of algebra. Move it over. So one more step, divide by 12, and we get y equals -2, but those are 2 lines. Make sure you give it to me in ordered pair. And there we go. Easy peasy. All right, let's try it again. This time I'm going to get rid of the y's. I can turn them both into 5y's, but one of them has to be negative. I chose the bottom one to make the negative, so the top stays the same. The bottom I have to distribute a -5 to every single term. I get 20x minus 5y equals -45. Add these together, the y's will disappear, leaving me 13x equals -39. X equals -3. Got to choose one of my equations. I chose the bottom equation. Put the -3 in for x. And now we just got to do a little bit of algebra 1, solving for y. And we get y is also -3. 2 lines, don't want those, I want ordered pairs. There we go. This one is just a little bit more difficult because things are not in the right order. Remember, I like to have the x's first, then the y's, then the equal sign, then the number. So we have to fix both of these up real quick. Once you have them in that order, it's just like the last 2 we did. We have to figure out which variable we want to get rid of. I think I chose the y's again. So they have both, I can turn them both into 90s. One of them has to be negative. Well, the bottom is already negative. So on the top, I have to multiply every term by 9. And you get 180x plus 90y equals 0. The bottom, I have to multiply every term by 10. Notice I'm putting the 10s there. For some reason, I forgot to put it by the -9y and the 30, but I would like you to see you guys do that. The y's cancel out, so I get 60x equals 300, and x equals 5. Halfway there, go back to one of the original equations. I believe I chose the top. Put the 5 in for the x. Do a little bit of algebra 1. Solving for y. And you're going to get y equals negative 10. Two lines, give me an ordered pair, and boom, we have an answer. So it's just a little bit harder, but not much. One more time with the things out of order. So let's rewrite them so that the x's line up and the y's line up. So the top is okay. Now the bottom, I could move things by changing their signs, or I could just rotate the whole thing. That's what I did, I rotated. All right, so now I have to decide what I want to get rid of. I believe I get rid of the y's here. The top one is already negative, so I left it negative. I gotta multiply the top every term by 2. So I get negative 20x minus 10y equals 50. I gotta multiply every term on the bottom by 5. This time I remember to put the 5 in every term. I got 30x plus 10y equals negative 50. Add these two lines together, I get 10x equals 0. That is not a problem because the x did not disappear. So x equals 0. 0 can be a number. So I come back over here, throw it into one of my equations. I pick the bottom one. Now I can solve for y. And y equals negative 5. Give me an ordered pair, of course. 0, x comes first, negative 5, the y comes second. Boom. Simple, simple, simple. Okay, now we just got to graph and shade. We need to graph by starting at the intercept, moving up the slope. I put 3 dots here. You only need 2. Make a solid line because it's or equal to. We can shade above because the y is by itself, or we could pick 0, 0. Of course, that's what I want you to do. Don't tell anybody else. All right, now let's do the second line, negative 3. Hey, wait a minute, these two lines have the same slope. These are parallel lines, so they don't cross anywhere. This one's dotted because it doesn't have the or equal to, but it is also greater than. So where do these two shadings finally cross? Right up here above the first one. And that's it. Let's graph one more time. These two are in y equals mx plus b. This time they are not parallel. So we start at negative 2, go up 1 over 3, make a dotted line because it's not or equal to. It's less than, so I'm going to shade down. The other one starts at positive 3 on the y-intercept, up 2 over 1, or down 2 over 1, whichever way you want to go. This one is a solid line. And this one shades above the line. So where do these two lines cross? In this little itty bitty area down here at the bottom left hand corner, right there. That's the only place those two things cross. Now on to the ones that take a little bit of time. I want you to start out by labeling them or numbering them 1, 2, and 3. I'm going to add 2 and 3 together because that will get rid of the t's right away. So I'm getting rid of the t's in both of these steps. I didn't have to change either one of them, so I'm just writing them down here, lining them up. I hate using the s's. You're going to see in a minute my s's start looking like 5s. I should have changed them to x, y's, and z's, but we'll get through. So I got negative, y's are an r right there. Come on. Let's erase that, change it back to an S. There we go. There's my fourth equation. So I'm going to leave that alone for now. Now I'm going to pick 2 other equations. I think I choose 1 and 3. I can't add them together right now because that wouldn't get rid of the t. So what do I have to do? Hey, I can turn that top t into a 3t. So I'm going to put a 3t there and a 3t there. I need one of them to be negative. Well, the top one is already negative. So I'm going to change just the top. To change the top, I have to multiply everything by 3. So go ahead and multiply. Make sure that you are doing all 4 terms. That's where we lose it if we miss it on this kind of question. Hey, look at my S. Doesn't that look like a 5? That's why I hate using S's. The bottom one can stay the same, so we put the bottom one down there. Again, looks like a 5. And then we just add the 2 lines together. Same sign add, opposite sign subtract, keep the sign of the bigger number. And there is my 5th equation. So now I get to choose, do I want to get rid of r's or get rid of s's? Because if I add them together right now, nothing goes away. So when I add 4 and 5 together, I got to choose which one. And I'm going to choose the r's. I can turn them both into 7r's. One of them has to be a negative, so I'm going to leave the bottom one negative and multiply the top one by a -7 because I got to turn it into a +7. So make sure that we don't make any mistakes with our negatives there. Rewrite the bottom one the way it is. Add these two lines together, and I'm going to get 26s equals -104. Divide both sides by 26, and you get a nice number, which makes me feel good about what we've done. Come down here to where I'm putting my answer. RST, S is in the middle. Now let's go pick one of the equations, substitute it in. I chose 4, by the way. Solve for R, just a couple steps here. I can put the -3 where the R goes. R comes before S, so I put it first. Then I pick one of the other equations up here. I'm picking 3, and I plug in the R and S. Do a little bit of algebra 1. Those are same signs, so I'm going to end up adding those two guys together, those -15 and -4. And then I'm going to end up moving it to the other side by making it positive, and I get 3t equals 15, t equals 5. And we've done it. We have solved a system with 3 variables. Good job. All right, last one here. Let's label our 3. And then we're going to add a couple together. I'm going to choose the y's to get rid of, because if I add 2 and 3 right away, the y's will go away. That makes life a little bit easier. So I don't have to change anything. I just write them down, line them up. And then we're going to just put a line underneath that and add them together. The y's will go away, leaving a 2x and a 2z equals 2. Now I'm going to take the two other ones. I think I take 1 and 2, and I'm going to add them together. Well, if I just add them, they don't go away, but I can turn them both into 6y's. So I'm going to write down a 6y and a 6y, but one of them needs to be negative. Well, number 2 is already negative, so let's leave that one negative. So I'm going to have to multiply the top equation by 2. So let's do that. And the bottom equation, or the second equation, by 3. Make sure you're doing all 4 terms, the 3 on the left and the 1 on the right. Okay, multiply that by 3. Put the line underneath them. Add them together. And now I'm going to get 2x minus 12z equals 72. Label it the 5th. Now I'm going to add the 4th and the 5th together. Now, some of you might be thinking, well, why don't we just subtract them because the 2x will go away? No, don't do it. We always want to add. So I can't add them together, so I'm going to make the 5th equation a -2x, which means I have to multiply it by -1. The 4th equation can stay the same, so I write it down. Distribute that -1 to all 3 terms in this 5th equation. Add them together. I get 14z equals -70. This makes me happy because z comes out as an integer, not an ugly fraction. I take that -5 and I put it into the 4th equation. I could have put it into the 5th, wouldn't have mattered. I don't force you to do either of those. You can pick whichever one you like. X equals 6. I take those two answers, I come back to 1, 2, or 3, and it looks like I'm going to do number 3. Put the 6 where the x goes, put the -5 where the z goes. Do a little bit of algebraic magic. Combine like terms and such. And now it's a 2-step equation where I subtract 4 and divide by 2. Now I have 3 lines. I don't want 3 lines. I want an ordered pair, alphabetical, x, y, z. So it's 6, -6, -5, and we did it. So it wasn't terrible. They're not fun by any means, but they're not horrible. All right, I hope this helps.